So in this example, it says you are conducting a study to see if the proportion of voters who prefer the Democratic candidate is significantly larger than 73% at a level of significance alpha zero point zero 0.01. According to your sample, 76.6234% of 77 potential voters prefer the Democratic candidate. Hmm. Okay. Well, so this is a hypothesis test, right? So whenever we have all these kind of, the HO, H1, that's always a hypothesis test. It even says, you know, yeah, study. I guess it's a study. Anyway, so let's try to make conclusions. So off the bat, what do we think? I mean, right off the bat, say, well, yeah, we're trying to figure out if the proportion of voters who prefer the Democratic candidate is larger than 73. It says we did a sample, and 76%, that's larger than 73, of the 77 people we studied, right? We studied 77 people, and 76% of them, which is more than 73, um, preferred the Democratic candidate. So yeah, that seems like more than 73. So what's the deal? Isn't it just a yeah, there we go. There's the answer. Well, why are we gonna do all this stuff? Well, it's because maybe this right here, maybe this was just a lucky sample. Right? I mean, that can happen, right? Life has randomness to it. Maybe we just got lucky or unlucky, whatever you want to call it. When we surveyed those 77 people, maybe we just had to happen to run into a crowd who really likes the Democratic candidate better. But really, on election, the truth is coming out in November on actual election day, and maybe it's way less than 73%. And you think, well, yeah, but your sample came out more than 73%. Yeah, maybe that was just a lucky sample. Just happened to run into a bunch of people who like the Democratic candidate by luck, and it's misleading us, and our our polling is wrong. Could that happen? Yeah, it could. So how do you get around that? Maybe you should survey more people. 77 is maybe not enough. How about 100? How about 200, 500, 1,000? How many people? Well, that's what the online calculator will tell us. In fact, it'll tell us exactly the chance of luck. Let me just tell you that in advance. The chance of luck is, or all right, let me, chance of luck, let's call it the probability of luck. Probability of a lucky sample. Oops, got the S there. Come on. Oh, okay. It's jumping around on me, and I don't need that. I'm a little tired of it. Probability of getting a lucky sample is called the p-value. That's the main, most important thing when we do a hypothesis test is the p-value. We'll get that in a minute, and that'll tell us the probability that that little sample we did was just luck. And that'll tell us whether we should have confidence in the results or not. All right, so here we go. Where do we start? First question. For the study we should use, it's going to be z-test for population proportion. We're getting that from the notes. Here's the notes. Here's the Unit 3 notes, page 2. It's let me erase what it's saying right here. Basically, if you look at this, it's telling you right here, type if it's a percentage question, use z-test for population proportion. That's ours. Ours is a percentage question, right? If you look up here, we're trying to find the percent, right? It says the proportion. So yeah, z-test for population proportion. Don't worry about what z is versus t. It's kind of a dinosaur. Forget it. Next, oh, whoops. No trouble there. There we go. Next, we have HO and H1. Okay. What are those? So HO right here. These are the two attorneys. HO says P, and it's always going to be equal. And down here we have um, P for, we're going to choose P instead of U. P for percentage. It tells us that in the notes right here. We choose P because it's a percentage question. And it's for HO, it's always equals. And for H1, it's P again, but it's greater, less, or not equal. So we come back and we go, okay. So is it going to be greater, less, or not equal? How do you know what that is? Well, you look for some kind of word, and this is H1, some kind of word up here in the original description that says more or less, bigger, smaller, something like that. Do you see anything like that? Oh, right there. There it is. Larger than 73%. So we're going to say, oh, okay. larger, greater than, and we always change this to a decimal, right? 73% becomes 0.73. So yeah, so this means the p-value is greater. P is on the wide side. P is larger, greater than 0.73. And then this means the other option is P is equal. These numbers are always the same. I forget the S. Always the same number. They're always the same number. Why? Well, because that way they're saying different things about the same number. This guy's saying the percentage is equal to 0.73. This guy's saying, no, the percentage is greater than 0.73. Percentage of what? Well, the real percentage of people who prefer the Democratic candidate. You think, well, we know what it is. It's right there. It's 76%. No. That was just for our sample of 77 people. We mean like in November on election day when the whole nation votes. Is the percentage on election day going to be equal to 0.73? Or is it going to be larger than 0.7? You think, well, what if it's less? Well, less would be included in this case, right? Because basically we're saying, is it larger or not larger? So less or equal would be the other case. So these are two attorneys, HO and H1, two options. And we're wondering which side has the stronger evidence. Is the stronger evidence here or is it here? And 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 you might have noticed in the notes. Well, let's just keep going forward. So to answer that question, back to the notes, we go to step 3. So now is it a percentage question? Yeah, it's not a mean. We're not doing mean. So it's a percentage question. So what do you do for percentage question? You get N, X, P0 and a radio button. So let's go back and put that in. I'm going to go. Oh, and which calculator are we going to? Uh, hypothesis test for a proportion. That's the online calculator. Hypothesis test for a proportion. Hypothesis test for proportion. So let's go there. That's the online calculator. And when we do, there's going to be, write them in here, there's going to be N, X, P0, and a radio button. Okay, and how are we going to choose it? Well, what is N first off? You know what N is. We've had N lots of times. It's always the total number of people in our study. What is X? It's the number we want or that did what we're thinking. So let's start with that. What is N? What's total number? Well, 77. There were 77 people in our study. Okay, what is the number that we want? What do we want? Want to find out how many people prefer the Democratic candidate. Well, it says 76%, 76.6234. Right, but you need an actual number. I mean, like a whole number. You can't put a percentage here. So how do you find that out? Well, you take that and you change it to a decimal. You put it right here. You take 0.7, says take this number right here. We go 0.76624 of 77. 76624 times 77. So we're going to go to our calculator. 766,234 times 77 on our calculator. So I'm going to go to like a Desmos there. I'm just going to go to a Desmos scientific calculator. You can get there, like if you, let me go back to, here, yeah, I'm probably confusing. Let me be a little more clear with you. Here we go. Here's the online calculator. And where are we going to the online calculator? We're going to hypothesis test. There you see hypothesis tests are 14, 15, 16. We're going to do number 16, hypothesis test for proportion. Click on that. Okay, it opens up. You see the NXP0, but see the little box that says scientific calculator at the bottom down here? I'm going to click on that scientific calculator. It opens up, and then I can calculate. Let me go back. What were we trying to calculate? We're trying to say, first off, N is 77, and then there's X. In fact, I should probably scoot this over for clarity and say this will be P0, and this will be radio button. Anyway, so in is 77. Let's go back. In here is 77. Okay, but to find the other one, I've got to take, what was it, 0.766 down here, the radio, but I gotta, I mean, on the online calculator, 0.766234, right? See what I'm looking right here? 0.766234 times 77. Why am I doing that? Well, because they told me 76.6234% of 77. We always change percentages to decimals. So that means, and of always means times, doesn't it? So that's why I come down here, I'm going to go times down here to find out how many people is that exactly. 76.6234% of 77. That means multiply the decimal by 77. So 766,234. Let me go back here. 766,234 times 77. Enter. Oops. Oh, I did a comma. Whoops. Well, let me try again. 766,234 times 77. There we go. Look at that. It looks like it's 59.000. So it's basically 59. So I'll come up here. X is 59 people. 59 of the 77 people. Let's put that back here for a second. This came out 59. Close, with a decimal, but you can't be part of a person. So what that means is 59 people out of 77. They surveyed, they asked 77 people, who do you prefer? 59 said the Democratic candidate. All right. And so now that tells you in the notes, by the way, let me show you in the notes right here, that has to be a whole number. Let me show you right here. We're on the percent proportion. N is the total number. X is the number asked for. This must be a whole number, not a decimal. If you're given a percent, like 20% of 80, then multiply. We just did that and round to the closest. We just did that. So P0 is the number from H0 and then the radio button. So we go, okay. So P0 here, P0 is the number from H0. It's H0. So that's going to be 0.73. That's what the little zero reminds you. The P0, go to H0, get the number. And then the radio button always comes from H1. Right there. Greater. So 0.73 and greater. Let's go back to it. 0.73 and greater. So this will be 0.73. And then the radio button, I'm going to choose greater. So I'm changing the radio button over there. Greater. And then calculate. All right, there's my Z, 0.716. There's my P, 0.2369. Let's go back and see those. Yep, get those right. See them right here. See the Z, 0.716, the P value, 0.2369. We got them right. So you'd fill those in. Now for it's decision time. Let's give it a go. How to make our decision? Well, they want us to take the P value and the alpha level, make a decision. Now, what's the P value? Well, we got it right here. It's a 0.2369. And then what's the alpha level? Well, alpha level is up here. Right there. At a level, so its alpha is 0.01. Oops, pass. This would be 0.01. So what's the story? Which one of those numbers is bigger? 23% or 1%? Well, obviously 23 is a lot bigger, right? So that is a greater. So that's why we chose greater. The p-value is greater than the, p-value is greater than alpha. 23 is much greater than 0.01. So what does that mean? What does that mean about our conclusion? Well, if you go back into the notes, it tells you exactly. So if P is less than alpha, you do all this, but that was not our case. We've got P greater than alpha. So what does that mean you do when P is greater than alpha? Well, when the P is not low, our P is not low, it's greater. The null must not go. Means when the P value is not low, the null must not go away. That is, fail to reject the null and say we keep the null, weak evidence. So I'm gonna go back and do that. So this means, here's the catch he's saying. When the P is low, the HO, which is the null, we call that the null. The null's a fancy word for zero. Like your check is null and void, zero. The null must go. See, it rhymes. When the P is low, the null must go. When the P is low, the null must go. Every stat student remembers it for a hypothesis test. Let's add the words away to be more clear, even though it ruins the rhyme. When the P is low, the null must go away. Okay, now, is our P low? Is our P value low right there? Sounds a little weird, the questions I'm asking, doesn't it? But it's not low. It's not. Oh, come on. Don't do that to me. There we go. Not low. It's not low. Why? Because it's greater. Greater is not low. If things are greater, they're not low. Right here. Right, or I could do it right there as well. Right here. This is greater. So it's not low. Right? Sorry. So right here, the p-value is greater than 1. 23 is greater than 1. So if something's greater, it's certainly not low. So in our case, then, the p-value is not low. So the HO must not. So you just add knots to both those. I'm just taking the handy saying down there. So we change it to be when the p-value is not low, the HO must not go away. So we're saying HO is not going to go away, which means what? Which means we're going to fail to reject HO. We're not going to reject it, right? HO must not go away. We're going to keep HO. So come down here and we say fail to reject the null. We're going to keep HO and weak evidence. It's all in the notes. It's right down here. Remember, our p-value is greater than alpha. 23 was greater than 0.1. So when the p-value is not low, it's greater. The null must not go away. That is, fail to reject the null. Instead, we keep the null and evidence is weak. So here it is. I'm just writing all that in. Right when the p is not low, it was greater. The p-value was greater. 23 is greater than 0.1. It's not low, it's greater. HO must not go away. That is, we fail to reject HO, fail to reject. We keep HO, evidence is weak, weak evidence. Okay, so what does all that mean? Okay, so well, that means we're keeping HO. So in other words, we come back up here and we say, oh, okay, so HO, this one, remember these were two attorneys. They were arguing. HO was saying the P is equal to 0.73. And HO was saying, no, it's greater than 0.73. Well, we're keeping HO, right? That's what it says, keep HO. Okay, great. So what? Well, and then so you're going to listen to what HO says. What does HO say? P is equal to 0.73. That's what he was saying all along, and now we believe him. We're keeping HO. P is equal to 0.73. We say, oh, okay, so P is equal to 0.73. There it is, equal to 73%. We believe in the end, the percentage of people that are going to vote in favor of the Democratic candidate, that prefer the Democratic candidate, is equal to 0.73. It's not greater. We did not go with the greater case. We didn't go that way, right? Because the two options were it's equal, it's just equal to 0.73, or it's greater than 73%. We ended up saying, no, we don't think it's greater. You think, yeah, it is. It's 76%. Yeah, that did come out a little greater, but that was only a barely little bit greater, and it was only 77 people. We think it could have just been luck. Really? What's the probability of luck? Our p-value, which is the probability of luck, came out to be 23%, or about 24 even. So the p-value, the probability of luck, is about 24%. So we're saying there's a 24% chance, pretty big chance, that the fact that this 76% is a little bit higher than 73 is just lucky. And that really, when November comes and everybody votes, the number that prefer the Democratic candidate's not going to be greater than 73. Our little sample was just luck. There's a 24% chance that our sample was just like, that's too big of a chance. If the chance is greater than 0.1, that was our level of significance. That means we want to know, we only want we want results that are better than a 1% chance of luck. Well, we didn't get it. We had a p-value, probability of luck, that was 23. That's too high. There's just too high a chance that our results are just lucky. So we do not think there's strong evidence. We're not going to go with the greater than 0.73. The evidence is just too weak. We think, no, probably on election day, it's just going to be equal to 0.73. There's not strong evidence that really more than 73% of the people prefer the Democratic candidate. The evidence is just got too big of a chance of luck, 23% chance. That's what the p-value is. Most important thing, the probability of luck. And so we in the end, we keep HO. What does HO say? Equal to 0.73. We say, no, we think it's just equal to 73% on election day. And so there we go.